All right, here we go. Practice test over 7.1 review. So here we go. Consider all of these numbers. So we got the digits 1 to 100. And we're going to pick a number. We want the probability it will be divisible by 13. Divisible by 13 is the same way as saying it's a multiple of 13. Okay? So I'm not going to explain that over and over again. You're supposed to know that divisible by 13 means exactly that. You can divide 13 into it without having a remainder. So, what are some multiples of 13? 13, 26, 39, 52, 65, I think there's another 78, and then 91. And the one that would come after that would be 104, which is out of our range. Now, for those of you that are struggling with coming up with the multiples of 13, 13 times 1, 13 times 2, 13 times 3, or you can just keep adding 13. You're sitting there with a calculator, so I do not feel one bit guilty about expecting you to know the multiples of 13 or any other number. Okay, who is that with a head down back there?
Solomon.
Solomon, get your head up.
Pay attention.
No, Solomon, get your head up. Up, thank you. When you get an A, you can put your head down. That's our deal, okay? Till then,
Quiz?
no, on a test. All right. Now, how many do I have here? 1, 2, 3, 4, 5, 6, 7 of them? So what would be my probability? I'm writing this as a probability, so I'm going to say 7 over 100. Why is it over 100? Because there's 100 numbers in that pile, right? So my total goes in the bottom. So 7 over 100, I would just leave it that way, but if you wanted to write it as a decimal, you could. Obviously, you can also write it as a percent, but it's probably best just leave it as a fraction, and then you don't have to worry about making any careless mistakes. All right, now we have students and teachers running and walking. And we have students, teachers, running, walking, 73, 5, 316, 72. So somebody collected this data. We're going to reach in and pick a person. What is the probability of getting a student walker? So a walking student. So if you look at your chart, walking student would be this number right here, right? 316? So where's that going to go in my fraction?
On top.
That's on the top. That's what we want. We want a walking student. Now what's going to go in the bottom?
Hold on.
Total number of students.
Sam? So 73 plus 316 is 389. Okay, what is the 389?
Total number of students.
That's the total number of students.
I want to get the total amount of
Exactly, Janaea. This doesn't say I'm picking only from the student pile. It says I have all these people in a pile and I'm going to reach in and grab one. So how many people do I have?
466.
How many is it?
466.
466. Now, you are responsible always for reducing the fraction. You can do this readily on your calculator by doing what?
316.
Type it in. So 316 divided by 466 equals, and then math, enter, enter. And it will reduce the fraction for you to what?
158 over 233.
Over 233. And that is the probability that if you reached into all of these students here, or all these people here, all these people, and you grabbed one, the probability is 158 over 233 that you would get a student walker. Now, what's the probability of getting a runner? Now, what's your denominator going to be?
466.
466. That is not changing. As long as we are picking from this pile, my denominator is going to be 466. But now I want a runner. So how many runners do I have? 78?
Yes.
This is the total runners right here. 39 over 233. Let's be kind.
I'm sorry, I'm just getting frustrated because I don't know what I'm doing.
Okay? Everybody okay with that one? So think about where we made, maybe you didn't, but where different people made mistakes. Remember, in a probability problem, what must be going into the bottom? The total. That's everybody. Total outcomes, that's everything. Right? Every number, so 100, or every person, so 466. All right, now we have our frequency table. And you are just supposed to find the mean. What is it? What does that mean? What am I doing when I'm finding the mean? I'm finding the average, right? So I'm finding the average value. And it's laid out for you right there with that F. What does that F stand for? Frequency. So that tells you that for that data value, 5, how many do you have? You have 1 5. But you have 5 6s, and you have 7 8s, and you have 6 10s, right? And we're gonna average all these. How do we average things?
You
Add them all up and divide by however many there are, right? Now, certainly, I don't advocate you writing all these numbers out. 1 5, 5 6s. I don't advocate that, but you have to recognize that you have how many? How many numbers do we have all together in this list? 19? Aren't there 19 of them? Look at your frequencies. Aren't there 19 numbers altogether? And to add them all up, you don't just add 5, 6, 8, and 10, do you? You have to add 1 5 plus 30, 5 6s plus 56 plus 60. And what do you get when you do that? 151. And then we do want an actual average value, so we'll go ahead and divide, and what does that come out to be? 7.95. So we don't know what this data represents, but let's say this represents the numbers of certain kinds of candy bars that we're eating. So the average is about 8, right? All right, that's our quiz. That's what we have next time I see you. So be ready for that. Now we need to get our sheets back out, our notes back out, and look at where we left off yesterday. And that is I think we're ready for number 5 on page 13. So I'm not going to fill all these numbers in. Ma'am, is it an emergency? Please leave your phone here. fill all those numbers in because they're all right there, but I wanted to make sure everybody understands what this table is saying, because I didn't write out any explanation. But what's going on is, people are going on vacation, and when they're going on vacation, they're choosing to either stay in a hotel, stay in a camper, stay in a tent, or rent an apartment, okay? And the data is categorized by age group. So, in the 18 to 30 age group, of all the people surveyed, 67 of them say I'm gonna stay in a hotel. So you understand how this table works? Okay. So now we're gonna answer some questions about the table. First one says, again, you have this huge pile of people. I'm gonna reach in and grab one out. What age group is he most likely to belong in? So in other words, which age group has the highest probability?
31 to 50.
And how do you know that, Hannah? You're right, but how do you know that?
Adding up all the numbers.
So you added up the cross. So you said, okay, the total number of people in that age group was what?
305.
305. And then the total number of people in this age group was? 529. 529. And then the 51 group?
286.
And then the bottom group? 210. So Hannah said, in order to find out which age group is the most common, I'm just going to figure out how many people are in each age group. Does that make sense? Perfectly logical. So this group has the most people. So if I reach in and grab somebody, isn't it the highest probability that I'm going to get somebody from this age group? So that's the question to A. That was easy. Now B says, what is the actual probability of that happening? So what is the probability of getting somebody in the 31-year-old age group? So Mamuna says, I'm gonna have to have a total. How does she know she has to have a total? Because if you're looking for a probability, isn't the bottom the total?
Yeah.
So how many total people do we have here? She's adding up this whole thing. 1,330. So that's your denominator. But now we want to know what's the probability of getting somebody in that 31-year-old age group. So what's the numerator going to be? 529, because that's how many people there are in that age group. Now, let your calculator check to see if that reduces. It might not, I don't know. It doesn't? So we know it doesn't because when we math bracket, it still comes up 529 over 1330. So that's the answer to part B. Now, C says, all right, this is the data that we are using. Okay, this is the data that we're using. All of a sudden, we're going to have some big event in our area, and we're expecting 16,000 new people to come in to our environment. So it's like you're having the Super Bowl, or you're having the Olympics, you're having some big event. And we know that our hotels, so all these people right here are staying in hotels, we know that the hotels can only hold 5,000 people. We only have room in our hotels for 5,000. So we gotta figure out if what? Do we need to build more hotels? Do you remember when the Super Bowl came to Indianapolis?
No. Yes.
They had to build more hotels, right? Because they didn't have enough. Are the Olympics like in Tokyo or something? I bet Tokyo is building hotels to handle the Olympics. All right, so who's got a plan? How are we gonna figure this out? We're trying to figure out if we have enough space to accommodate our new tourists that are coming in to stay in the hotel. Who has an idea? You know how to do this, we did it yesterday.
You're gonna do the expected, yeah.
I'm gonna find the expected number of hotel people, aren't I? And how do I find the expected number of hotel people?
You take
How do I do it?
the number of people coming,
So I take the number of people, so that'll be 16,000, and multiply it by what? Not by 5,000.
By 13.
Look back at your notes, how do you find it? By what? The probability of staying in a hotel. I'll use the math notation. That's not pH like in chemistry, that's the probability of a hotel. Okay? So I gotta figure out what the probability is that people will stay in that a person would stay in a hotel. And then I'm gonna multiply that by 16,000, and that's gonna tell me how many people I have to plan for. Now, how do I find out the probability of staying in a hotel? Mikey? Add what all up?
Add all the H column.
The H column. So I need to add this column now. These are the hotel folks. So do you have that, Mikey?
Yeah, 370.
370. So the probability of picking somebody from the hotel, or that will stay in a hotel, would be 370 over 1330. Or I'll go ahead and reduce that because I can tell easily that reduces. Here's my probability that a random person will stay in a hotel. That makes sense? There's this many hotel people out of 1330. So the probability someone will stay in a hotel is 37 over 133. So the probability is that number, and I've got this many coming. So I'm gonna take that number times 16,000, and that's gonna tell me the expected number of hotel visitors. What is it? 4,451. So if I am the city planner, or I am the chairman of Hilton Corporation, or Hyatt Regency or something, am I gonna decide to build more hotels, or am I gonna go with what I've got? I'm gonna go with what I got, because I'm only anticipating 4,400 or 4,500, and I have 5,000 rooms. Think that kind of stuff really happens in the real world?
Yeah.
Absolutely. It's used all the time in athletics. How many of you follow professional or collegiate sports and have heard the announcers or the coaches talking about analytics? This is analytics right here. Very simple analytics. But the Colts have people on their staff, and all they do is this kind of stuff. Not with hotel rooms, but with the athletes.
Oh.
No, not with hotel rooms. They got that part figured out. But how fast a guy runs, how many injuries a guy's had, all that data, they can analyze it and make predictions on who's the best person to draft. It's a whole new branch of mathematics. Very exciting. You're into it. All right. Number 6.
Yes.
Here we go. A letter is chosen from the word laundry. What is the probability it is a vowel? Well, again, this makes the assumption that as seniors in high school, you know what the vowels are.
A-E-I-O-U.
A-E-I-O-U. No, we're not going with the sometimes. We're going A-E-I-O-U.
Yeah, we're not doing that.
Okay? A-E-I-O-U, those are the vowels. Okay? So, what's the probability that if I pick a letter, it's going to be a vowel?
5 over 6. 2 over 7.
1 7.
2 7.
So I heard 2 7s. Do I hear anything else? Why is it 2? Because there's 2 vowels. Why is it 7?
There's 7 letters.
7 letters altogether. Perfect. Find the expected number of consonants drawn in 32 trials. So what that means is, you got these letters in a hat, you're going to draw one out 32 times. Now you always put them back. So you draw one out, write it down, put it back. What are the expected number of consonants you would get if you did this 32 times? How do we do this? You know. 32 times 5/7. And where did the 5/7 come from?
The amount of consonants there are.
That's the probability of getting a consonant. So the probability of what you want is 5/7, and you're going to try to get it 32 times. So what does that end up equaling? 22.18?
No, 86.
Oh, 86.
When you want us to round it to 20.
Oh, yeah. We're not going to get consonant 22.86 times, so we're going to say about 23 times. This, by the way, is called theoretical probability because you know that if you actually did this experiment, let's say everyone in the room had his own little bag of letters and you all did this experiment. Would you all get 23? No. That would be experimental probability. This is theoretical probability. This is what should happen. And theoretical probability is good if you're looking over the long term. Like if I did this experiment with my class every year that I taught, by this point in time, my average would be 23. But the first time I did it, my average might be 24 or 28 or 19. Who knows, right? All right, next. In a class survey, Billy, Annie, Kate, Macy, Shiloh, and Q said they love math.
That was a good one.
Billy and Macy also love science, and Mamuna loves English. Kayla, Solomon, and Marcella also love English. Anthony and Hannah don't like any of these subjects. Draw a Venn diagram.
Oh my gosh.
All right, so here's my Venn diagram. All right, so I'm gonna take this one step at a time. Here is my math circle. I'm gonna label it math. And inside of it, I'm also going to draw a science circle over here because Billy and Macy are in both circles. Would you agree with that? Now, I'm only looking at math and science right now. I know I got to get English involved. But would everybody agree that Billy and Macy are in math and science both?
Yes.
Now, what about Annie and Kate and Shiloh and Q?
They just like math.
They just like math. So are we good so far? All right, now, Mamuna loves English. Now, does it say anything about Mamuna and science? No. So English, Mamuna is out here in English. Here's Mamuna. And she's out there with Kayla and Solomon and Marcella. And that circle is not connected to the other circle. Would you agree with me?
Yeah.
Okay. And then where do I put Anthony and Hannah?
Not in the diagram.
Not in the circles. So Anthony and Hannah are out here. They're in the set, they're in the box, but they're not in any of the circles.
They can't get a circle.
They don't get a circle. We don't put circles around the nons. We leave them floating around in empty space. Okay, so there's our Venn diagram. Is everybody okay with that? How many people are in the box? I've heard 10, 12, and 13. How many people are in the box?
It's 12.
There's 12 students in the box. Just count up the names. There's 12 names. Now, why do I need to know that? Because the very next question talks about probability. And I know if I'm picking a kid out of this class that my denominator is going to be 12, right? Find the probability of choosing a student at random. So here is, think of this as a box. I reach in and grab one. What's the probability I'll get someone who loves math? How many people in that box love math? 6. Very good, Mamuna. There are 6 people in the math circle. If you are in the math circle, you love math. God bless you. So your probability is 1/2. Remember, we always reduce our fractions. Now B says, reach in, grab somebody who loves math, but not science. How many kids love math, but don't love science? 4 of them. These guys right here, these guys love math, but they don't love science. How many love all 3? None. There are no students in this survey who love all 3. So the probability of loving all 3 is 0. You don't have any. What's the probability of getting somebody that loves exactly 2? Exactly 2, isn't that just these guys right here?
Yeah.
So that probability would be 2 12ths or 1/6. Everybody okay with that? All right, number 2 is another Venn diagram. All right, so Sam, what's happening in this Venn diagram? Okay, so we got all these kids, we got 26 of them in the box, and they all like math except for these 4 out here who don't do anything, right? They're out there. And the rest of them study algebra or geometry, right? Now, notice that I have overlapped my circles. All right, so I want you to think about this for a second. This has to make sense to you. Okay, there's 26 of you in the room, let's pretend. We don't have that many here today, but let's pretend there's 26 of you in the room, okay? I send 4 of you out to the hallway because you don't do either one, okay? So now how many people are in the room? 22. All right, I say, raise your hand if you're studying geometry, and 10 hands go up. And And then I say, raise your hand if you're studying algebra. 16 hands go up. Now wait a minute. How many hands went up? 26. But how many kids are in the room? 22. Which means what? Somebody raised his hand twice. Right? So let's back up till we figure it out. There's 22 kids in the room. 10 hands went up, and then 16 hands went up. So how many hands went up? 26. There's only 22 kids in the room. So what does that mean? They doubled up, which, how many? That's what I need to know. How many doubled up? 4. So there are 4 kids. How did we know there were 22 kids in the room?
Yeah.
Okay.
We took out the 4.
They're out in the hallway because they're not raising their hands. So they're outside. So I have the 22 math kids left in the room. Macy, is it an emergency? I mean, school is out. Okay, hurry up. Leave your phone here, Macy. Your phone must be here. Okay, then you can leave it right there. All right, so this is critical, folks. Does everybody understand how I did this?
Yes.
Now, the algebra, these are the whole A circle are all the kids that study algebra. This says that 16 are studying algebra. This is not 16. What is that? That's 12. Because the entire circle, A circle, is 16. 4 of them are also in the G circle, that's fine, but they're still part of the A circle. So there are 12 right here. What are these 12? Who are these guys? What are they doing?
Algebra.
They're taking just algebra.
Yeah.
Don't say they're taking algebra, because this whole circle's taking algebra. They're taking just algebra. Now, how many are taking just geometry? 6 are taking just geometry because there are 10 taking geometry, but 4 of them have already been counted. So you have the just algebra, the just geometry, and the doublers. Okay. That's your Venn diagram. How many study both algebra and geometry? Now this just says how many, so it's not a probability. How many study both algebra and geometry? 4. So the answer to B is 4. Reach into the class, grab somebody. What's the probability that he will study exactly one subject? How many study exactly algebra? 12. How many study just geometry? 6. 20. So everybody else either studies nothing or 2. I don't want to count them. So how many kids are there that study exactly one subject? 18. And what will I put that over? 26. Or 9 over 13. You can't do these problems fast. You have to read each word carefully because the word exactly one matters. Right? These guys are exactly algebra. These guys are exactly geometry. They're the only ones I can count in this problem. Okay? Ay, ay, ay. Alright, oh Lord, look at what we got here now, number 3. We have 113 kids. So the box holds 113. And they're asked what they read. And the choices, the things they respond to are they read novels, magazines, or tweets. Okay? Now, it tells me that 42 kids read all 3. So all 3 of these circles must overlap. And right here in this space must be a 43. Would you agree with me? I have a novel circle.
It says 42.
Oh, it says 42? Oh, yeah. 42, read all 3. Thank you, Luna.
No.
So I have a novel circle, I have a magazine circle, and I have a tweet circle. And they all 3 overlap, and there's 42 kids in that spot. Would you agree? Okay. Now, there's more information over in the other column. It says there are 6 kids that read only novels. So look at the novel circle. Where is that 6 going to go? They read only novels. Won't that fill this spot right here? Because these kids right here are only reading novels. They're not part of any other circle. And 5 read only magazines. And 8 read only tweets. Hannah, in about 2 minutes, this is going to look really familiar to you. Because she came to Flex yesterday when no one else did, so she got a head start. Now, what have I not put in my diagram yet? 88 kids read novels, right? Now here's the problem. That means this whole circle right here, the whole thing, is 88. Don't put 88 here. Don't put 88 here. 88 is the whole thing. So I'm going to call this X and this Y, and I'm going to write an equation that says 6 plus 42 plus X plus Y equals 88. This entire circle, all the parts of the circle, have to add up to 88. You see what I did? Now, the whole magazine circle has to add up to 76. So I'm going to call that section Z. And 5 plus 42 plus Y plus Z equals 76. All the parts of the magazine circle add up to 76. And then what am I doing with the tweet circle? What's that going to look like? 8 plus 42 plus X plus Z equals 85. You can't put 88, the number 88, into your Venn diagram because the 88 circle has too many sections. And 88 doesn't represent any section, it's the total. So that's why we said all the sections all the sections of that circle add up to 88. All the sections of this circle add up to 76, and all the sections of this one add up to 85. Okay? That's a mess. Let's clean it up a little bit. What is 6 plus 42? 48. I'm going to subtract that over here. So what is that equation going to look like once I get that taken care of? X plus y equals 40. They can't solve that. That's where we are so far. Let's do the same thing with the middle one. What is the middle one going to say when you do exactly the same kind of cleaning up? Add this and move it over. It'll say y plus z equals what? You have a calculator. 29. And let's do the same thing with the bottom one. It'll say x plus z equals 35. Now we have to solve this system of equations. Now you know how to do that. This is a little bigger than normal. Normally we just have 2 equations. But now we've got 3 because there are 3 variables. And one of the cardinal rules of mathematics is if you have a system of 3 equations, then you're going to have 3 variables. 4 equations would be 4 variables and so on. Okay. Who remembers how, when we just had 2 equations, how did we solve them? Shoot, I'm out of room here. How did we solve them when we only had 2 equations? Do you remember? What?
You gotta solve for one first, so.
Okay, so you can substitute. So get x by itself and plug it in. What else can we do besides substitution? What's the other thing? You can eliminate. And both of those will work fine. Here's my suggestion. I'm going to take these top 2 equations. Hannah, what am I going to do with my top 2 equations?
I multiplied the top one by -1.
Okay, now let's stop a minute. Here's what Hannah did. She said, I'm going to multiply this top equation by -1. Now I'm going to add them together. So I have a negative x, a negative y, a y, and a z equal to a -11. I just add them together, add everything up. So negative x, negative y, positive y, z. Now what happens when I do that? The y's cancel. That's why she did it. Now you're saying, but wait, Mrs. Ford, you still have negative x plus z equals -11. I still can't solve that. But what if I paired it up with my bottom equation? What if I took negative x plus z equals -11? That's the new equation that we got when we did what Hannah said. We added these 2 together. And I got this. What if I combine that with this equation? What's going to happen when I add them together? I'll have 2z equal to 24. Is that right? So z is 12. Let's back up. The first thing, we had 3 equations. So the first thing we did was add the top 2 together, and we eliminated the y's. That's the letter they had in common. We eliminated that. And that left us with an equation that we could then combine with the other equation, our third one. And we lost everything, got 2z equal 24, so z is 12. So this little section right here is 12. Now what? I can plug it in like right here. If I know that x plus z is 35, but I know z is 12, can I figure out what x is? What's x? 23. So this little section is 23. How am I going to figure out what y is? Could I plug it in here? Because now I know x is 23. So 23 plus y is 40. So y is 17. Remember that big area problem we had on our test where we had to split the thing and find the angle and all that stuff? This is the monster problem on this test. There's a lot here. We haven't answered the question yet. What's the question?
How many read nothing?
How many read nothing? So we got 113 people in this box. Let's add all these up and see what we get, because we've got all these people are in the circles. So take out your calculator and total all these up. Add all these up and tell me what you get. So you're adding up each individual number.
113.
Does it work out to be 113? Okay, so wait a minute. All these add up to 113. That's everybody in the box, right? So how many are floating around out here in space? None. They're all categorized. So if the question were, what's the probability of choosing someone who reads nothing, you would say 0, right? Now wait, we're not going to do any more, but you got to stay with me because I'm going to ask you a couple questions about this. All right? What if the question were, what's the probability of novel and tweet only? So what's the probability that if you reached into the box and grabbed somebody, that that person would read only novels and tweets? Here's the novel circle, and here's the tweet circle, right?
23.
Now they overlap in this whole chunk. What do these people do in the 42? What do they like? They do it all. I'm not interested in them. They like it all. What are these 12 right here? They do tweets and M's. They do tweets and magazines. I don't want them. What do these 23 do? They do novels and tweets. So these 23 right here are only novels and tweets. So what's your probability? 23 over 113. Okay, one more. You're gonna do this one on your own. We're gonna check your answer, then we'll be done. Excuse me.
Bless you.
Thank you. All right, so what's the probability that you reach in and grab somebody who only reads one thing? What's the probability that you grab somebody who only likes one kind of thing to read? Don't say it out loud. Take a minute, figure it out. All right. Macy, you got an answer? What's the denominator going to be, Macy? Yep. So we got half of it done, 113. let's look at the end circle, okay? What did we say that 42 meant?
Everybody does that. You know?
Everybody, they're reading everything. They're reading everything, okay? What do we say something like this 17 right here meant? 17 is part of the N and the M. So these are the people that like novels and magazines? Okay, what are these 6 right here? Just novels. One thing, novels, right? Are there any other people up here that just have one thing? 5, they only have magazines, and the 8 only have tweets. So how many is that altogether? Well, I think it's 19. I think it's 19. So your probability, oh, that's 100. Your probability would be 19 over 113. Because these are the people that only read one thing. Okay? It's easy. Building the Venn diagram is not hard. Once you get it built, it's not so bad. I'll have to come up with a couple more of those for next time. All right.